Okay, so today we are going to work on using properties of logs to expand and compress or condense log expressions. So today we're not going to be solving any equations. Tomorrow we are going to use this to solve equations. So we've looked at some like basic log and exponential equations. Tomorrow we're going to look at some that are a little bit more complex. So to do that, we have to know all of these properties of logs. These should be ones that you have seen before in Math 3. However, I usually find it's like they're kind of, a lot of times students don't remember them. So you have to kind of be reminded of them. So our first log property that we need to know is called the product property. And it tells us that if we have a logarithm with any base of two things that are multiplied together, we can split them up into log base b of m plus log base b of n. And conversely, if you have two that are separated by addition, you can put them together using multiplication. So this could go either way. So let's look at what you'll be asked to do. The problems you're going to get, some of them are going to ask you to expand and some will ask you to simplify. So if you are asked to expand a logarithmic expression, you want to take this and break it apart. And simplifying, you want to put everything together. So whenever I have something like this, log base 3 of 4, that's times x because they're right next to each other. The product property tells me I can break this up into log base 3 of 4 plus log base 3 of x. Okay, so that expands. Sometimes we're given things that are already expanded. We want to condense them. So we can do, for this one, we would have log base 7 of 9 times 8. And of course, since those are actually numbers, we would write that as log base 7 of 72. This probably won't be an issue for most of you because you came from Coach Wood, and I just do not see him. Well, a few of you are Miss Martin, but I don't think she's really picky on it either. When it comes to showing work, there's going to be very few things that I'm going to require you to show every step on. So, like, I usually would not write this middle step right here. It's perfectly fine with me if you skip steps. There will be some stuff I will require you to show work on just because I do not believe that anybody is capable of doing the whole problem without any work, but I do believe that you could photomath it without any work. But as far as like individual steps, I'm never going to be real picky on that, with the exception of trig identities, in which case we have to show every step, but we'll talk about that whenever we get there. So there, for the most part, skipping steps is fine, sometimes even good, because it means you understand it well enough to do it in your head. So, and for some of this, it's going to be, you can do the whole thing in your head and just put the answer if you're really good at that. For others, maybe not as much. So, next property, quotient property. If we have two things that are divided, we can break them up with subtraction. Okay, so if I have natural log of 4x over 7 and I'm asked to expand, I could break it up this way: natural log of 4x minus natural log of 7. Now, this one will expand further. What other property could I use to help me expand here? I could use that product property because I've got 4 times x. So since that's multiplied, I could do natural log of 4 plus natural log of x. I'm going to put some parentheses around that because I have grouped that together. Technically, on this one, you could get away with doing it either way because order of operations would have you put these two together first either way. But in general, if you are doing like a secondary step where you break something down again, I'd put some parentheses around it. Sometimes it matters there. Okay, so if I see something like log of 9 minus log of 3, they've got the same base, so I can combine those and make this log of 9 divided by 3, which of course is just log of 3. Okay, everybody with me there? Any questions? All right. Okay, power property tells us that if we have log of something raised to a power, we can pull that power out front as a coefficient. So it's like you're taking this exponent and it's pulled out front as what we call a coefficient, which is just a number multiplied by something else. So here are our examples here. So for this one, I could pull this 3 out front. So I would have 3 log base 3 of 4x. And here's a place where your parentheses are important. I can break this down further, right? It is important, though, that when I break it down further, that I put parentheses right here, and I'm doing log base 3 of 4 plus log base 3 of x. Without those parentheses, the 3 would only be multiplied by just this first term. But it should be multiplied by the whole thing. So you want to put those parentheses there. So that's why I say it's just safest to always put the parentheses around, like if you're doing a secondary step after that. Safest just to put those extra parentheses. Because sometimes you need them. Sometimes it could go either way, but it's never going to be wrong to have them. Okay, questions? All right, over here, I've got log base 2 of x and log base 2 of 4. I want to put those together with multiplication, but I can't do that while I've got this 2 and this 3 out front. So what I need to do with these coefficients is I need to put them back in as exponents. So they have to go back in as exponents. So that's going to be log base 2 of x squared plus log base 2 of 4 to the 3rd power. And I'm going to go ahead and do 4 to the 3rd power, which is going to be 64. And then my last step here, because I'm adding these together, I can combine those logs using multiplication. So, oops, what's it doing? That'll be log base 2 of, I'm going to write it 64x squared. It's just more standard for us to put the number first. You can write x squared times 64, but it doesn't look very standard there. Okay, questions? Just to get a gauge on where we're at, did you guys see this in Math 3? You remember seeing this stuff, maybe don't remember how to do every bit of it, but you saw it. Okay, so I'm seeing, it looks like I'm seeing yes from most of Coach Wood's kids, even though, wait, who was Miss Martin's? You were Miss Martin's, okay. And you were Mr. Brown, right, okay. So, that might be our difference there. Okay. All right. Okay. Equality property, we really already did this yesterday. This is Coach Wood's favorite property. The equality property tells us if log base b of m equals log base b of n, then m has to equal n. So this is just your drop the logs property, right? We were doing that yesterday because it's kind of just common sense that that has to be the case, because if you've got log of something and then the same base log of something else, you know those two things have to be equal to each other. So if we have a problem like this right here, this is sort of inching towards what we're going to do tomorrow. You won't have a problem like this tonight in your assignment, but this is inching towards what we're going to do tomorrow. So for this, if I have this equation, can I drop the logs as they are right now? I can't, because it's not just log of something equals log of something. I got this 2 out here. So we just learned a property. What can I do with that 2? It's got to go back inside as an exponent. So that's going to be log base 3 of 4x equals log base 3 of x plus 1 squared. And now, since I just have logs on both sides that have the same base, I could drop those logs there, and I'll have 4x equals x plus 1 squared. Now, pre-calculus is a beautiful class because it makes you remember how to solve every equation you've ever seen. So like when you were in definitely Math 2, maybe a little bit in Math 1, like one of us may have just given you a problem that looked like 4x equals x plus 1 squared, and you probably knew how to solve it then. However, now, far away from that, many of you might be thinking, I don't know what to do with this anymore, right? So we're going to see stuff pop up that, like, within these log equations, we also have to remember to solve a quadratic. This is going to be a quadratic equation, or we don't have to use the quadratic formula, but it's going to be a quadratic here. So it pulls together so many things, which is really great because it helps you review all of those things that it's been a long time since you did as well. So, anybody? Let's see if anybody can impress me. Anybody remember how to solve this? Okay. Impress me by telling me how to square that x plus 1. Okay. All right. If you do the box, that is fine, and you can continue to use the box. I will say at this point in your math career, it's going to be really good for you if you can do this in your head. If you don't have to draw out the box each time, because a lot of times like this multiplying out is like an intermediate step, just like this little step in a much bigger problem. So if you don't kind of get caught up, if you can do this part in your head, it's going to make you faster. So if you use the box, or this means x plus 1 times x plus 1, right? So you're going to be doing x times x, which is x squared. Then you'll get, I'm going to write this over here actually, x squared plus, you'll get a 1x, and then another 1x, and then a 1. If you're using the box does the same thing. That should be what you get in the middle. So the shortcut for this is that these middle two terms are always the same. You're just doubling it. And the last term is always the square. So I always tell students to square, double square. I don't know if anybody's told you that before.
Wouldn't it be 2 for that last number?
It's going to be not 2 for the last number because it's 1 times 1. You're multiplying there. But so you're going to square the first. So x squared is x squared. All right. Then you multiply these two together. X times 1 is 1x. And double it. So you get 2x right here. And then you square the last, which 1 squared is just 1. So if you can do that in your head, so that's another, we might add that to warm up stuff too. Because if you can do it in your head, it just makes life a little bit easier. But if you can't yet, write it out, it's fine. So, what do we do now? Okay, so I'm going to subtract this 4x. So 0 equals x squared minus 2x plus 1. All right. What now? If it'll factor, that's going to be the fastest way to do it. If it won't factor, you could always complete the square or use quadratic formula. Or even if it does factor, you could still use those options. But factoring is going to be fastest here. Oh my, what's happening? All right. Okay, so this will factor. And hopefully you guys are good at factoring because we're going to use it a lot in this class. If it's something you need to, if you need some practice with factoring, it might be something you want to come in and look at in Smart Breakfast because we will do factoring. We will factor a lot in this class at different times. So here, I got to have things that multiply to give me x squared, so that's x and x. I got to have numbers that multiply to give me 1. So the only options for that are 1 times 1 or negative 1 times negative 1. Which one should I use? The negative ones, because I got that negative 2 in the middle. And these numbers should add together to give me that middle number. All right, you guys remember factoring, doesn't it? It shows that you do it in Math 1 and then you keep doing it every class. And then you keep thinking maybe it'll go away, but it never does. I factor in calculus, you factor, all the time. And until you graduate and don't have to take math classes anymore, you will be factoring. So, what's the last thing here? Set equal to 0. So since they're exactly the same, you're really just doing x minus 1 equals 0. So x is going to equal 1. So that's your answer. Okay, questions? Let me check time. Okay, we got. Oh, we're still good. Okay. All right, so you are going to have an assignment on Delta Math today, and this is what the problems are going to look like. So, like for example 8, it asks us to condense the logarithm. So that's simplifying. We'll put those back together. And some of this is going to have ones that aren't even letters here. So don't get your computer out for Delta Math yet because I want us to do these that you have here first together. I don't want you to work ahead just yet. So, for example 8, what's the first thing I'm going to need to do? I can't do anything while I've got these things outside of my logarithms, so they've got to be pulled in as exponents. So I'll have log base b to the 8th power. I'm sorry, not log base b. Log of b to the 8th power minus log of d to the q power. And then, with the subtraction, what do I use to put those together? What is that? Quotient where we divide, right? So we will have log, log of b to the 8th power over d to the q power. Okay. Another way that you're going to see them word basically the same type of question on Delta Math is it's going to say write the expression below as a single logarithm in simplest form. So that means the same thing as condensing that logarithm there. So for number 9, we've got a number out front again. I don't know why it keeps skipping ahead. We got that number out front again. It's got to go in as an exponent. So that's going to be log base b of 5 to the 3rd power. And I believe in Delta Math it doesn't let you leave it like that. You would need to do log base b of, you're going to do 5 to the 3rd power, which is going to be 125, and you would type it in like this. questions there? Okay. Whenever you see problems that are wanting you to expand on Delta Math, it's going to say expand the logarithm fully using the properties of logs. Express the final answer in terms of log x and log y. What that means is that it can't be, you can't stop early. Okay. So for this one, we've got division. We use subtraction to break up division. So we would have log of x to the fourth minus log of y squared. Now, that has expanded it some, but it's not expanded fully, and it's not in terms of log x and log y. So, Maggie, what do we need to do? What else do we need to do on this problem? Okay. Our issue, whenever it says in terms of log x and log y, it means we got to have just log x. It can't be log x to the fourth power. So that fourth power right there is in our way. Same thing over here with our y. We can't have that squared. So those exponents, somebody help her out. What can we do with those exponents? They can be pulled out to the front like that, like your coefficients. So that'll look like this: 4 log x minus 2 log y. So when it says in terms of log x and log y, it means that in the end, you can't have anything else inside of your logs. They have to be, everything has to be cleared out. So if you typed in log of x to the fourth minus log of y squared, technically that is equivalent to this over here. It's just not expanded as far as they wanted it to be expanded, so it's not going to count it right for you. Okay. For 11, it's the same deal, except for this time we've got log x, log y, and log z. We've got 3 variables, right? So, let's see. Lennon, what do you think we should do first on this one? Over here, we've got exponents, we've got multiplication right here, and we've got division, right? The exponents we can't deal with yet because they're all different, right? So we have to hold on to those. Whenever you have multiplication and division, you want to deal with the division first, if it's like something over the other. So things that are divided, what sign do we use to break them back apart? Subtraction. So we got log of x cubed y squared minus log of z to the fourth. So then we can break this apart further. Right here we have multiplication. So let's see. Kendall, what could we use to break that apart? We can do that over here for that 4. But we cannot do it here for this one yet because we have 2 different exponents in here, and these have to be separated before we can do that. So you can, whenever you're pulling that exponent out, it can only be a single exponent that you're pulling out there. So we can do this over here. What could we do to break these apart at? Right, so we're going to have log of x cubed plus log of y squared. minus, I'm going to leave that z to the fourth and do it all at once here, but you could go ahead and pull the 4 out if you wanted. So now that you've got it all broken apart, and technically, I would put, it wouldn't hurt to put some brackets around that right there. In this particular case, it's okay to not have the brackets because order of operations you would add first before you subtract anyway, in this case. There can be times when it's going to be wrong if you don't have the bracket there. So I would, I would go ahead and put the bracket. So now we can take our exponents and pull them out front. So this exponent will go here, this exponent goes here, and this exponent goes here. So we end up with 3 log x plus 2 log y minus 4 log z. Yes? It's okay. I like to put them there just to differentiate. Like, it would be assumed in that case that log of x to the third is log of x to the third, like that. However, like, if you had something, which you won't see much, like this, there would be a difference. So I like to include the parentheses just to specify, but you don't have to have it. Around the whole log. I just used a bracket because brackets are parentheses. The only reason that we typically use brackets is if we're going to have a parentheses next to another parentheses. So just like aesthetically, a lot of people don't like for that to happen. So if you use parentheses instead of brackets here, that's perfectly fine. Right. This is not, within an equation or expression, brackets act just like parentheses, so it's okay to have parentheses instead. It's just a lot of times textbooks or programs will use a bracket instead of a parentheses so that they don't end up with one parentheses right next to the other. Yeah. Okay, questions? Okay, now these are the ones students usually find the most difficult on the homework that you guys are going to have. So I think they're good problems though. You are going to run into a little more of this fractional exponent stuff. It's going to give us some trouble though. Okay, so fractional exponents. This is what we ran into on the homework, that one question that we had where we had b to the 1/2. If I have x to the a over b, that equals the b root of x to the a power. So if you get any of these problems where you have roots, for example, right here we got the square root of b to the 3rd power. What you want to do with them so that you can proceed is you want to change these to fractional exponents. So a square root does not have a number out here for the root, but what number is it assumed to be? Is a 2, right? So even though it's not written there, that is a 2 right there. So to write this as a fractional exponent, it's going to be b to the 3 over 2. So the exponent goes on top, the root goes on the bottom, because roots go on the bottom of the tree, so that's where it belongs. All right. So that's the first thing we're going to do if we see a square root pop up. We are going to write this as log of b to the 3/2 over a to the 7th, c to the 7th. So if you end up with any roots, switch them to fractional exponents first, because trying to do it with the root is not going to be possible for us. All right. Then what we want to do is we want to break this apart into log A, log B, log C, just like we were doing the last problems. And it's going to have one more thing different at the end. So here I've got a fraction. When I have fractions, I want to break those apart using subtraction. So that's going to be log of B to the 3/2 minus log of A to the 7th, C to the 7th. I'm going to put, you don't have to put those parentheses, but I'm going to. Okay, so we broke up our division. Next, we want to check to see if there's any multiplication that we can break up. Do we have any? Right here, I've got A to the 7th, C to the 7th. So I'm going to break this up like this. Log of A to the 7th plus log of C to the 7th. And it's important here to either put those brackets or an extra set of parentheses around this part, because you're subtracting that whole thing, not just the log A to the 7th. Without those parentheses, you'll get the answer wrong on this one. All right, we got one more thing to do to finish breaking this down. What do we need to do? What we need to do, Monica? Move the exponents out. So our exponents right here, we got 3/2 goes out front, 7 goes out front, 7 goes out front here. So that'll look like this. We got 3/2 log B minus 7 log A plus 7 log C. So much like the last problem we just did, we've broken this down all the way. Here's the twist for these problems. They want a numerical value for our answer, and they told us that log of A equals 5, log of B equals -4, log of C equals -11. So what we're going to do here is it tells us log of A equals 5. So where I've got this log of A, I can just put a 5 there, right, because it's equal to 5. Where I have, oops, sorry, keep flipping. Where I have log of B, that equals -4. So this log of B can be replaced with a -4, and our log of C is -11. So I can replace this with -11. So this is how it will look. I'm going to go over here so I've got some more room. I'll have 3/2 times log B, which is -4. I've got 7 times log A, which is 5. And 7 times log C, which is -11. The logs are gone completely here. So 3/2 times -4 is going to give me -6. You got these parentheses here. This is going to be 35 minus 77. That's going to be -42. That double negative right there becomes positive, and you should get 36, I think. This stuff will be calculator active. You can use your calculator for that part if you need to. Although it's really good mental practice to not do it unless you really recognize it's going to take you a long time. It's really good to do that without a calculator, just for your own mental exercise. Okay. Questions on those? All right. So, oh wait, we're not going to do this because it is we are going to do it tomorrow, but I'm not going to do it right now. You won't see it on your homework. So I'm gonna skip these two so that you got about 15 minutes to. That way you'll be able to start on your assignment. All right. You guys are going to go to Delta Math. For today, you need to go to Canvas first. And if you will go to Canvas, there under day 2 is a homework assignment that says Properties of Logs, Delta Math. And the reason you need to go here first is because you need to be added to my class for Delta Math. So you're going to click on that link right there, and it will add you to my class for Delta Math. Although I don't want to do that because I don't want to add myself to the class. So you'll click on that link. It will add you to the class for Delta Math. Then you should see, oh, I have the date set wrong on that. Let me change it. Because it shouldn't be in the late credit section. Set the date wrong. Let me fix that. This is due tomorrow at 10 a.m., not today at 10 a.m. Okay. Now, when you get into Delta Math, you should see here homework 1.2 Properties of Log. That's for today. And it's going to give you these. It is going to ask you to do 20 questions. So for Delta Math, it does show me how long you spend on the assignment and how many questions that you have done. So for these, preferably you will just do all 20 and get them right, and it not take you too awful long, and we'll go about our lives. However, if you're getting stuck on some of this, on Delta Math, what do I usually say? On Delta Math, I never intend for you to have homework that's going to take you 2 hours to do. So if that is happening, then you're not understanding something correctly, and that is why it is taking you so long. Now, if you work a little more slowly, it may take you a little longer than some other students, but never should you spend 2 hours on your math homework. So, on Delta Math, I can check how long you have worked. So, now on worksheets, like I did last time, I'm not going to let you guys tell me you did 30 minutes very often. I'm going to most of the time make you do the whole thing. But it was the first day and we didn't have any time to work on it in class. For Delta Math, I can see what you're doing. So do not spend any more than 45 minutes on it. You do not have to spend any more than 45 minutes on this. I think you should be able to finish it more quickly than that. If it's taking you longer, I think there's something you're not understanding well. Now, if you tell me you spent 45 minutes and I go and look, and it tells me that you spent way less, I'm not going to take your word for it because Delta Math will tell me. And I'm not exactly sure, like it may pause out, so like if you're on the problem for 5 minutes, I don't know if it counts the whole 5 minutes there. I'm not sure because I haven't compared it side by side. So, if you're taking a long time on each problem, you might want to go a little bit over. And if I have some students that tell me, Miss Hyatt, I tried and I just got them all wrong and I couldn't do it. And then I go and look and they did 3 questions. And they got one of them right. So they only missed 2 questions. That is not missing enough questions. Delta Math will show you the explanation. It also has these help videos that you can watch. So those sometimes can be helpful if you're stuck on something. So if I see you watched a help video and you still missed 3 or 4 problems and you were really stuck and you spent 45 minutes on trying to do something, then I can work with you. If I don't see that, then you're not going to get full credit on your assignment. So go ahead and start on that. You got about 10 minutes to do some of those problems. I'll be around to help if you have any questions.